Hi guys. So quickly give me some hellos on the live chat so that I can know that I'm audible to you and the stream is working properly because for the next 1 hour you don't want any problems to occur, right? So yeah, waiting for your highs. Okay. Hello, that's a lot of enthusiastic folks today and yes, so we promised you a special guest today and today we have her with us, Nikita Gandhi, who is managing the program for Explore ML. You all know what the Explore ML program is, but yes, I leave it to her for introducing it to you. And yeah, without wasting much time, without you guys having to see my face for a long time, I'll actually hand over the session to Nikita. So yeah, Nikita comes in now. Hi,
Hello,
Nikita.
everyone. Yes, thank you, Anubhav, for inviting me today. It's a pleasure to be a part of this session, and thanks for organizing more and more sessions in ML. I hope students are enjoying it and getting benefited out of it. And the knowledge that they get out of the sessions, I hope they'll be able to use it to add it to more of their projects, bring out some interesting solutions that can solve for the country, that can make lives easier for everyone to live. Um, so I'll give a short introduction for myself before we begin. As Anubhav mentioned, I manage the Explore ML program in India. I belong to the Google AI team, and yeah, so I work as a project coordinator at Google. Before joining Google, I was a Women Tech Makers ambassador, and I was also working at a startup which was a joint collaboration between Japan and India. I also had my startup, which couldn't succeed to the market probably, but yes, that's a little bit about me. Just like you, I started my journey in the community as students, as a volunteer, as a participant, and community gave me an opportunity to organize events, to speak, to enhance my leadership skills, and I am today. I really believe in bringing in equal learning opportunities for all. So, what my hobby is also what I do as a full time job these days. So, I'm really lucky to have a job which is also my passion. Uh, so, without taking more of this time on introducing myself, I know you're very eager to hear about ML, and that's what I'm going to talk to you more about. Okay. So, are you inquisitive enough? What is machine learning? Why is it trending so much? How is it overcoming the traditional programming approaches, which was a primary source of bread and butter for so many engineers? And why does it sound magical, or why does it make a startup product sound fancier when it is composed with machine learning technology? Before we understand what is machine learning, let's try playing this game Quick Draw. I'm not sure if you've heard about this game before. Have you played this game before? Anytime? Feel free to add your comments in the live comments section so that it becomes an interactive session for all of us. Okay, can you go to the link which is marked on the screen g.co/quickdraw? Okay, so this link is going to prompt you a game which asks you to draw different objects, and your computer or your phone will recognize if you've drawn the object correctly or not. So this is more of testing your drawing skills again. Have a look. It's one of the most interesting games we've come across, which is an example of machine learning. Let me know once you're done with the game. Okay. Um, I hope you got sufficient time to scroll through this game. And now let's understand what was this game about, how does it work, and if you were given a task to program a similar game, what would you do exactly? So first, let's try to understand how does machine learning work in Quick Draw. Um, so if you were told to draw an apple can be of different shapes as you see on the screen. An apple can have leaves, an apple can be half bitten. Some of them may not draw may not close the entire loop. It can be an apple as a technology product sign, so on and so forth. So how does the machine understand or predict different samples of images as apple or not? So, if you were to solve this program using a rule based approach, that is traditional programming, uh, what exactly you would do is you'll write a series of if else conditions or rules. So, if the object falls in the set of rules, it is true. If it doesn't, then it's not an apple. So you'll have to write different dimensions, colors, or different permutations and combinations, how exactly you would like to define an apple, so that your machine understands what is an apple. Um, or you can use a machine learning approach where you give your machine a set of sample images which can be compared, and based on the sample examples which are given to the machine for reference, your computer will recognize if you've drawn the object correctly or not. So, what is the what is the advantage of machine learning approach? uh, Basically, the size of the code goes down, and you don't have to think about different permutations and combinations on how exactly you would describe an apple. Instead, you just provide sample images, and more the number of images, more accurate your training model will be. So okay, so that is what Quick Draw game was about. It was more of providing sample data sets for your system to recognize how exactly an object would be defined, labeled as, and accordingly it compares with the training data set and gives you the right answer. But do we really need to use machine learning approaches all the time? Uh, or you can actually replace it with rule based approach. For example, if you had to create a list in an alphabetical order with which has songs, we can go ahead with a rule-based approach. But if you had to rank web search results, it can be based on the user ratings, or it can be based on the content that is there. So in this case, both the approaches can be used. But if you had to predict housing prices based on the location, so say that I want to predict a house price in Dadar in Mumbai. So the prices will be different than the houses price in price of houses in Navi Mumbai or any other suburb region. So even in a, a place like Dadar, there'll be like places which has really beautiful houses, and the price of house will be different over there. And if it is surrounded by some uh, like, if it doesn't have, it is not surrounded by shops, or it doesn't have any convenient bus stops, then the prices of house may go down. So you cannot keep on defining the set of rules to predict the housing prices, but it would be more of a machine learning approach, which takes different parameters to predict the prices of the house. But if you had to process payments online, which is more of a mathematical approach, you'll use a rule based machine learning approach. Or if you had to classify an object in a photo, then it's going to be a machine learning approach wherein the system learns what an object actually looks like, compares that object with its learning in the past, input object with the learnings in the past, and accordingly tries to classify an object. For example, if I had to classify sun from different images or photos, and I have trained my system with different scenarios on how a sun would look like, then next time when I give a sample input of a nature image, my system can compare with the images in the background and give accurate results accordingly. So each of the programming approaches has its own benefits, and there is no right answer to which one is the best approach. However, uh, rule based approach gets improved every time you write more and more rules to the algorithm, while in machine learning learns from examples and patterns of data. Okay. I hope I was clear enough by now. And if you have any questions, feel free to ask them in the live comments. I would want this session to be very interactive, else you all will doze off and feel like, oh, it's 10:30 at night, and why is she speaking so much? Or might be you just fall asleep and we don't even know about it. Okay. Any questions from the audience? No questions? Okay. Uh, so I'll proceed. Okay. So I'll proceed with the next slides. Okay. So what is machine learning, and how is Google using machine learning? So how many of you use Smart Compose feature in Gmail? Okay, so that is an example which predicts what would be the next word while you are typing, and is an example of uh, machine learning. Or your emails are classified into spam or not spam, is again an example of classification, which is an approach in machine learning. Or if you had to search a cake image in your photos, again machine learning approach. Or if you maps predicts how much time will it take to for you to go from one location to another, and has some approach of machine learning also used in it. um, yeah, so Google is trying to use more of ML in all of its products and making it even smarter every day. So, yes, this is something that we always hear, artificial intelligence, machine learning, deep learning. So, AI, ML, why are they always coupled with each other? What is the relation between artificial intelligence and machine learning? So, as you see in the picture, artificial intelligence is the entire world, and machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. So, what tasks your computer can do intelligently is artificial intelligence. The tasks that involves learning from the machine, and you train it with sample images, is an example of machine learning. So you first train your machine, and then it tries to implement things by itself, and is an example of art, and it's then called as artificial intelligence. While deep learning is where different models are connected to each other, and so it's more of a complex model which goes through different processes. So that was about artificial intelligence, machine learning, and deep learning. Yes. So an interesting question that I could see. So data science is more about learning from the data and predicting from the data. So you gather a lot of data and you apply logic to it. That is data science. So reinforcement learning is more of a deep learning approach. They are pretty much similar. Okay. So we proceed further. So, what can machine learning do? So, now we understood that what was the difference between traditional programming approach and machine learning approach. How is Google using machine learning in its products? Then we also tried to understand what is the difference between artificial intelligence, machine learning, and deep learning. Now, let's try to understand what machine learning can exactly do. What is the scope of ML as a technology? Before that, let's talk about uh, different models that are used in machine learning. So, the first one is classification. So, say if you were given an example of a animal and you had to classify if it's a wildlife animal or a domestic animal, so on and so forth. So, if you had to classify it into different categories, then it's classification. Clustering, sorry, regression. So if uh, they had to predict how much time will it take for you to go from one point to another, or if an ad is populated, will the user click on that ad? It's an example of regression. Clustering. Uh, so clustering is more about identifying an object, recognizing an object, and giving it labels. So say that we all have different handwritings, right? So uh, I can write seven in a particular way, and I can. Everybody has different styles of writing seven, but after all, they all are seven, isn't it? So we label all the different styles of writing seven into a particular label called seven. And next time you ask your system to recognize this digit, it will compare with the labels that you had created, and if it falls into the label set that you had given as a training input to your system, then your computer can recognize that the provided input is digit 7. So okay. So what is the difference between classification and clustering? Like, a lot of students get confused understanding the basic difference between classification and clustering. So classification is more of classifying objects. So basically, you differentiate different objects. And clustering is done after you apply classification. So first you classify it and then you provide it labels. So in machine learning, all the nearest numbers or data are grouped together and is an example of clustering. While classification is a binary approach, it can be spam or not spam. It can be a wildlife animal or a domestic animal. While in clustering, similar data is grouped together and given labels. Okay, next. Recommendation. So this was one of the most popular video that we had seen at Google I/O 18. If you remember, it was more of booking an appointment, and Dialogflow was doing it for you. So it was recommending you how you can book your appointment and all. So that was an example of recommendation. Sequence prediction. So, more often in English, Q is followed by U, and that is where sequence prediction can be used. Or if you're writing the word there and I just write THER, might be it becomes obvious for the system to predict that THER will be followed by E and makes the word there. So, I hope you understood what was classification, what was clustering, what was regression, what is sequence prediction. And we also have one more model to talk about, which is style transfer. So, style transfer is about mixing two objects into one. So, for example, you mix a voice of a male and a female to a new voice, or you mix two images to create a new image. And in an example of style transfer. All right. So, was that too much of ML, or you want to listen to more from my end? We can talk about more of ML provided you are not sleepy and I'm not bugging you. Okay. Okay. Okay, there's one question. Why is it called logistic regression if all it's doing is classification? Uh, Rishiraj, can you refer where are you talking as logistic regression? I could not get what exactly are you referring to. Okay. Meanwhile, Rishiraj comes up with the question. We can proceed as more and more of you are interested to learn more. Let's play this game. If you could tell which type of machine learning approach will you use to recommend someone based on the previous purchases. So, say for example, someone is buying a pair of shoes. Possibility that he will also buy socks is very high. So this is an example of recommendation, and it's a sequence. So you first buy shoes, then socks, so on and so forth. So it's sequence prediction. Labeling an email as spam or not? Okay, this is a very easy question, and of course, it's classification. Okay, identifying trends amongst people who have bought a new music release. Uh, first, what you do is you classify different types of music. and then you cluster group of people together who like pop music or who like jazz, who like classical, so on and so forth. So that is an example of clustering. Okay, I just missed a question that was populated on the screen. Could we repeat the question? Can't sequence prediction be a rule-based approach like search for all the words beginning with provided sequence and suggest what the user types the most number of occurrence of the word? Yes, Sandeepan, that could be one of the approach your system could use. Although, if it is learning from the set of rules that we are providing, maybe we don't add all the set of rules and we may fail adding all of the rules, and might be the system is not accurate enough. And if we are defining the set of rules, it's not a machine learning approach. Okay, the next question is logistic regression gives output as an instance belonging to positive class or negative class. But that is also what classification does. Isn't that regression for continuous data? Yes, you're right, Rishiraj. So logistic regression gives output as a binary format. It's positive or negative, and that is also what classification does. But what regression does is it sets a threshold, and anything below the threshold is so it works with more of data points. It works with more of numbers. Um, so yeah, I mean you're not completely wrong. Okay, shall we proceed to the next slide or do we have more questions to take? Okay, I'm proceeding with the next listen. Captioning a video. So, a video is what? A set of images, one after the another. And if I had to give a caption to a video, it will go through the set series of images, try to understand what that image has to say, and accordingly suggest a caption for the video. So first, it breaks the entire series of video into images, reads like decodes every image, and then gives a caption, which is an example of style transfer. Determining the workout activity based on phone movement. So if I had to determine based on the person's movement, if he is a fitness enthusiast or does a lot of sedentary work, I'm classifying the workout activity based on the phone movement. So it's classification. Predicting the strength of the password. So predictions are more of an example of regression. So it's regression this time. Identifying people in a photo. So you classify an object in a photo, and an example of classification. Suggesting spelling corrections. So first you label the data and try to match with the input data the user will be providing. If it doesn't match, then we compare it with the nearby labels and then suggest for spellings, and is an example of clustering. Predicting whether a user will click on ads based on its position and quality. Prediction, it's all about regression. Estimating arrival time based on the time of the day and traffic. So, estimation and predicting is regression. Translating between two languages. So, translations are more of style transfer. Okay, I hope you understood what different uh, models speak about. What are different models in machine learning? What can machine learning do? What was the basic difference between AI, ML, and deep learning? And what was the difference between classification and clustering? What was the difference between traditional programming and machine learning approach? Predicting passwords, yeah, we can classify it as strong, weak, but it can also be like predicting the strength of the password in uh, a linear scale. So, say that your password is 30% strong, so on and so forth. Okay, I can have more questions if you have, or we can proceed further. Okay, there's one more question. Is logistic regression more based on finding a best case using a lot of data, while classification is used to group data together under broad headings? Then how does it become different from clustering? Okay, so I'll explain the concept of classification and clustering again. Might be it's confusing. So classifying is just about classifying. So say that I have a classroom of students. I have to classify if a student is a man or a woman, and it's an example of classification. Now, if in the same classroom I had to find out average students, best performing students, and below average students, so I provide them with labels and I classify students if they're average, below average, or above average. But to do so, how will I do that? So each student is mapped with percentage. Okay, and students with a group of percentage which are similar to each other are grouped as are grouped as, say, average. Another group of students with similar percentages and around can be grouped as, say, above average, so on and so forth. So that is an example of clustering. So you're clustering average students together, you're clustering below average students together, and you're clustering above average students together, and then you're giving them labels, which is classification. Classification do not group data but gives probability for each class for the given input, whereas clustering is all about grouping the data even without knowing what class it belonged to. So clustering is more about grouping similar objects together. So I form clusters of objects which are closely related to each other. Classifying is classifying it into categories. So it can be a category of man or woman, strong or weak, so on and so forth. I hope the concepts were clear to all of you, and we can proceed with the next concepts. So classification is labeled data, clustering is unlabeled data. Yes, correct, Sandipan. Can clustering be generalized as more than one classification? Not exactly. I mean, as we spoke, there is a pretty wide difference between what is classification and what is clustering. Which approach to take to predict size of any object in an image? Okay, so if you had to predict the size of an object, you are doing mathematical computations, right? And it's an so you're predicting, and whenever you do predicting, it's a regression approach. Okay, are you enjoying the session, by the way? Is it informative or is it boring? Is it adding value to your knowledge? Okay. Um how many of you have ideas that you want to implement and involves a machine learning approach? Yes, recognition is a part of ML. Okay. Oh, that was a very nice compliment to know. Ayush, thank you so much. Okay. So I'm sure you all have innovative ideas to implement which involves a machine learning approach. So I'm going to talk more about how to approach a problem in machine learning. Okay. Before that, I'll play this video. I'm not sure if it will be audible, but let's try. Okay. This video is a bit lengthy, and I just thought of keeping it short because if she keeps speaking, then I won't get a chance to speak. Okay. Uh, so let's move on to the next slide. So let's try to understand what is a machine learning process. So while you approach any problem, first thing first is focus on the user, focus on understanding what the user wants. Try to define the use cases very clearly. That is where you will define the objective and the scope of the project you want to work on. accordingly start collecting the data. So you may not gather data easily. It's very hard to get real time data. Users may not feel comfortable sharing their personal data. um, so it is a hassle. It involves a lot of hassle, but although I would suggest uh, spend a lot of time on collecting the data, because the more better your data is, the more accurate your training model is going to be. After you have gathered the data, train and test the model. So train your system with different algorithms we discussed. So train it for classification, maybe you train it for regression, and then you test it with the sample data you have collected, and predict how accurate your system is working. Predict how it can work with different samples of data. If the prediction is say 40% accurate, there is more chance of improvement. So go back, collect more accurate data on which you can train your system, test it for that data again, and predict the accuracy. So this is how you'll understand how accurate your model is, and that's more of how a machine learning process looks like. Okay, so I hope this was clear, and we can move on to the next slide. So here's another video which I find really interesting.
Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this?
Okay, there was a question, if the data is changed, do you have to do all the steps? Your algorithm remains the same, but you're testing it with different data. So, so how exactly I would define a machine learning process would be something like, consider your machine learning model as a baby who's trying to learn from its parents. So whatever you as parent are going to teach the machine, it's going to learn from that. So give them right examples to learn from, give them more and more examples to understand the concepts better. uh, yeah, so when should I stop collecting the data? When you feel like your system is giving you accurate results, you can stop collecting data.
This? How about this? You may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. Just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's selection bias, like this recent game where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to to adding a feedback tool on the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation. Because technology should work for everyone.
Well, that was a beautiful message to understand that technology should work for everyone. We should build products that can help everyone. Is it possible to remove biases from a model completely? After all, as humans, we are all biased in one way or the other. Yes, we are biased, but that is what this video has to say. Like, think with an open mind. Just do not assume things, but anticipate from all directions. Work with an open mind. We cannot remove biases completely, but the less the bias, the more accurate your model is going to be like. Uh, Farooq, I do not understand which party are you talking about? Okay. And there's one more interesting video that I have to play. I know I've been playing a lot of videos back to back, but these videos are very cool and explain a lot of things. So I thought of sharing all of them with you.
Lots of people to make successful predictions. What happens when that data is sensitive? Credit card numbers or medical results. Sometimes sensitive data is needed to train a model so they can make accurate predictions. But at the same time, this data must be carefully protected. This is the challenge of machine learning. Let's look at an example. Suppose you create a machine learning model to diagnose illnesses based on a person's symptoms. Someone who reports a stuffy nose and a cough might receive the diagnosis the common cold, whereas someone else with the same symptoms plus a high fever might be diagnosed with the flu. Plenty of other factors might influence the diagnosis too. Does the patient have a medical history of similar symptoms? Did she recently travel to another country or spend time on a farm with livestock? Are other family members or roommates sick at the same time? To train this model, you could feed it information about thousands of people in those symptoms, medical records, and demographic information. This data includes plenty of personal information that needs to be protected. In addition, the data sets involved might contain other private information not directly relevant to medical diagnosis, such as patient contact information or the credit card number used to pay for medical records. What steps should you take to protect user privacy? Step 1 is to gather and select only the data that your ML system needs to achieve its goal. The less private data you have in the first place, the less you need to protect. This might seem like common sense, but it takes effort. It's easier to copy a whole database than to spend hours removing the parts that you don't need. Step 2 is to identify any data in your data sets that may be sensitive. For example, names, addresses, telephone numbers, email addresses, government information, and other personally identifiable information, or PII, should be kept private. Another type of private information is user-generated content, such as email messages, YouTube videos, blog posts, and any other content created by users. Be sure to work with your product counsel to determine which types of information are considered private and how to handle them. You also need to make sure you have permission to use the data and whether the data has other privacy restrictions. Be sure to work with your product counsel here as well. Step 3 is to protect the private data. You can do this by controlling access to the data and your ML model, or by altering the data so it's not recognizable anymore, or both. Privacy is a critical concern in machine learning. When you maintain privacy, build trusted workloads, and protect your company's interests.
Okay. So yes, that was about machine learning. So involves a lot of complex steps. They are not just complex, but lengthy steps. Requires repetitive iterations. Requires a lot of struggle when it comes to data. But overall, it makes your system intelligent, and that's the best part about machine learning. While you work on data, you'll collect a lot of personally identifiable information. You may feel like you're just doing an hobby project. Why do you need to secure that information? But after all, you'll be using real time users data for this. So if it's sensitive information, it's very important to protect it at different layers of model that you'll be applying for the machine learning process. It may sound boring. You may be in a hurry to wrap up the project if it's just a final year project that you're working on. But remember that data is everything in machine learning. It may create wonders, but it may be a harmful activity for someone whose data is leaked out just because you are not careful enough. Um, Also, we understood that just don't graze behind the cattle because ML is trending. You may have different motivation to learn ML, maybe just as a hobby, maybe to get a right job, maybe to get a high paid, well salary job. Maybe you have some project ideas to implement which requires machine learning. Um, but keep in mind that uh, all of this is fun. Make this process interesting, but at the same time be careful, be wise, be intelligent with the data you will be dealing with. uh, with that, I hope you understood with the recap what is ML, what is rule based versus machine learning approach, what is AI versus deep learning versus ML, different classification models, and the way of implementing ideas for your machine learning projects. We have another 5 minutes. Is there any questions I could answer? Feel free to drop them in the live comment section, and I'll be happy to answer them. Sensitivity of the data is, yes, of course, it is relative in where it is used. But I would say if it is a personally identifiable information, it has to be kept secure. Is the process of explicitly training our model lengthy for general data sets? Uh, yes, it's lengthy because you need to provide your system with more and more data. Yes, Rishiraj, we aren't misusing the data, but a hacker may misuse it for his own or her own personal benefits. Yes, Nishant, it's an example of a style transfer converting voice audio into text. Okay, any more questions? Uh, any feedback that you want to share? Did you enjoy the session? Was it boring? Anubhav, you need not remove the personal data. It's just about encrypting the data and keeping it secure so that hackers are not able to attack it. Ayush, when we talk about securing the data, say that you're working on a healthcare project which involves persons' personal information. Um, it is a risk if the data is exploded to a hacker or a wide range of audience, right? It can be misused, it can be misled, or even if you say that you have collected a data about geography of Kolkata, and this data is leaked, and maybe terrorists use it for their own purposes, for planting bombs or for planting some threat to us. It's a risk, right? You were using that data for say some project which involves predicting the prices of the house, but if this information is caught by some terrorist which can be misled for something else, it's risky. Okay, thank you so much all for your kind appreciation. I'm really glad that you enjoyed the session. In case you want to learn more about ML, we can do another session in the coming days. Meanwhile, if you have any feedback to share, feel free to share your responses here, or maybe you can tweet uh, your feedback. If we are running out of time, feel free to tweet it on Twitter, and let me know how much you enjoyed. Thank you so much, everyone, for joining. And I think it's pretty late for you to have some good sleep. Uh, if you don't mind, we can sign off for today, and maybe if required, we can meet in the upcoming days. I wish you all very best. I hope to see interesting projects coming in the future. I hope you all develop something interesting using machine learning. And let's stay in touch on Twitter. Nikita Gandhi is my Twitter handle. Nikita with double K. Gandhi, it's my Twitter handle. So feel free to tweet, and we can stay in touch on Twitter. Maybe Anubhav can share my Twitter handle for everyone to chime in and stay connected with me.
Thanks a lot, Nikita. Um, yeah, we crossed some records today on the live stream, so thank you for that. And yeah, it was pretty interactive. Like we had so many questions today. I'm sure like this was the largest volume of chat that we had on the live stream for the first time. And thanks a lot for your time. Thanks a lot for joining us and answering all the questions that we had. And any other questions that might be coming, there are still some. We'll be
Oh,
sending
okay.
them your way through other mediums. We can answer them and we can get the answers to the people who have asked them. So if we have missed any of your questions, then please don't worry. We'll find answers to them and we will get them to you. So thanks a lot, Nikita. Besides that, I have a few things to quickly announce. So I'll be doing that wisely. Um, so tomorrow's session. So tomorrow we have a session on a quick introduction to Python for data science by Shashwat. So yeah, guys, join us tomorrow as well. We usually have it on alternate days, but since Nikita was there with us today, we'll have it tomorrow at 10 p.m. same time. And yeah, we are having an event, the Cloud Fest at our college, which is being hosted by DSC, NSEC, and GTC Kolkata on 21st of September. So you can find this event on the GTC Kolkata meetup page. And finally, the largest thing I have to announce today. Um, no one knows about this yet. So yeah, this is the best moment to announce it, I guess. The DSC Winter of Code. So what this program is, basically we are going to uh, have some open source projects on which members will be working for 1 month to understand how the Google Summer of Code program works and how they can increase their chances of getting selected to it next year. We are going to prepare from now, right? So for 1 month, we'll be doing a lot of open source code. This is open to all members of DSC and NSEC as well as anyone who wants to join in, right? So there's no restriction to this. Just like we do not have any restrictions on the Intro to ML program. Yeah. So we'll be coming up with more details about this program soon. Guys, thanks a lot for joining us today. We had a huge participation, and this is how you can get to us, how to reach us. We have a website, you can go there and register to become a member. We have a Facebook page, we are on Twitter, we are on Instagram, we are on Medium, wherever you can find us, right? Just go to any website and do a /DSC NSEC and you'll probably find us. So guys, thanks a lot for joining us today. Thanks a lot, Nikita. Thanks a lot, Shagda, who is there on the live chat. Shagda is GD and co-organizer for GDC Kolkata, along with Indranil Da, who is also there on the live chat. And the core team of DSC and ACC is there on the live chat, and you can see them on the comments right now. So guys, thanks a lot for joining us today. And yeah, these are the people who made this big today. And the program that still continues for the next 25 years. Yeah. Thank you guys. Thanks a lot. Good night.